This course module will familiarize you with the Profibus Protocol. After completing this module, you will be able to name the details of the Profibus DP and PA protocol and communication, know the device installation and address setting, know the data traffic and protocol, name the profile and blocks, and you will know important facts about the cycle time. Profibus is a master-slave system. There are masters of Class 1 for cyclic data traffic, DPVO, masters of Class 2 for acyclic data traffic, DPV1, and masters of Class 3 for cross-traffic, DPV2. It's possible to connect several masters to a Profibus line, provided that they are Class 2 masters. A Class 2 master always has a low priority, and therefore only temporarily gets the logical token for communicating with the slaves. The slaves, Profibus field devices, are polled by the currently active master one after the other. Once the Profibus DP and PA network, cables, junctions, couplers, power supplies, etc. has been set up, the field devices, slaves, can be installed. When the first field device has been connected to the Profibus network, the device-specific driver file, General Station Description or GSD file of this field device is loaded into the engineering system, and a communication is established with the field device. In the next step, the default Profibus address 126 is changed to a free address between 3 and 125. Note that the addresses 0 to 2 should be reserved for the master. The before-mentioned procedure is repeated for all other field devices you want to install. It's important not to run two field devices with the same bus address simultaneously on the same Profibus line. Profibus field devices have no fixed position on the bus. This means the bus addresses may appear in any order. The principle of cyclic user data traffic is as follows. On the left you can see the Profibus DP MasterCard, Distributed Control System, DCS, and on the right a Profibus field device, slave, with the example address 3. The master requests the slave to transmit the current measuring value. The slave provides the measuring value within microseconds and transmits the requested value to the master. When this action has been completed, the master polls the next slave with the next higher bus address, and so on, until the last slave on this Profibus line, for example with address 125, transmits its value to the master. After this, the master restarts with the first slave, address 3, and again requests its current measuring value. The time until a slave is polled again is called the cycle time. The more field devices, slaves, are connected to a bus line, the higher the cycle time. In addition to the most important measuring values, the field devices cyclically transmit diagnostic data. When a field device detects an error, it also transmits one time the standard diagnostic data to the master as an octet string, 4 times 8 bits. Additional manufacturer-specific diagnostic data are also possible. They depend on the corresponding field device type. For example, PILD, plugged impulse line detection information, can be transmitted for 266XXX pressure transmitters. In the boxes you can see here, the standard diagnostic data for the field devices are listed. The great user benefit is that for the first time, profound information from the field devices and their connected peripherals like valves, pipes, and so on can be transmitted to the distributed control system. Predictive maintenance is thus made possible, especially due to other manufacturer-specific field devices' diagnostic data. This kind of data transmission is not available for 4 to 20 mA devices. The Profibus organization has specified profiles with a focus on the following goals. Interoperability, the ability of easy interaction between field bus devices from different manufacturers on the same bus line. This is a fundamental prerequisite for the success of the Profibus technology. Interchangeability, easy replacement of field bus devices of the same type but from different manufacturers. In practice, however, this will not happen too often and is rather negligible. Basic functionality, consistent operation of the field bus devices of the same group. It's possible to parameterize all devices of a group, like temperature, with a universal driver, GSD DTM, although this is limited to the basic functionality. This feature, too, is not frequently used, as the users often want to set the manufacturer-specific parameters as well. The Profibus profile also defines the block concept. What does this mean? In the illustration, you can see a Profibus transmitter with the measuring cell on the left and a Profibus connector on the right. The gray box represents the field device housing. The light blue boxes are the field device electronics. Every field device includes 3 different blocks. The physical block is the first block. It stores all general device data such as the Profibus address, manufacturer name, hardware and software revision, tag, and so on. These parameters can be read and written acyclically, represented by the thin light gray arrow in the illustration. The second block is the transducer block. In this block, the mechanical or electrical measuring values from the measuring cell or sensor are digitized for the first time. Also, the measured value is evaluated in this block. If an error should occur, this information is cyclically transmitted in the 1-byte status together with the 4-byte measuring value. This action is represented by the thick dark gray arrow. Of course, acyclic reading and writing of the parameters is also possible. See the thin gray arrow. The third block is the function block. In this block, the digitized measuring value is processed. For example, a limit value is set. The measured value plus the corresponding status is then output for cyclic transmission to the master. See the thick dark gray arrow in the illustration. Of course, parameters can also be read and written acyclically, represented by the thin light gray arrow. Although there are only 3 different blocks per field device, the transducer block and the function block may exist several times in a field device. These blocks have their own 4-byte measuring value and 1-byte status each, which they transmit cyclically to the master. Acyclic reading and writing of parameters, represented by the thin light gray arrow, is also possible, of course. The user benefit is that, for the first time, more than one measuring value and additional status information are available from a single field device, which is not possible with a 4 to 20 mA device. The Profibus profile data structure for cyclically transmitted values has a data length of 5 bytes. These 5 bytes are composed of 4 bytes of measuring value information and 1 byte of status information. The 4-byte floating point measuring value has a high precision due to its high 32-bit resolution. When a field device detects an error or status change, the status byte is set accordingly and transmitted to the master. The possible combinations of the 8 bits are arranged in 3 groups. The first box lists quality statuses. The second box lists the quality sub-statuses. The third box lists the limits. The great user benefit is that, for the first time, profound information from the field devices and their connected peripherals like valves, pipes, and so on can be transmitted to the distributed control system. Targeted maintenance is thus made possible. This kind of data transmission is not available for 4 to 20 mA devices. Besides the number of bus devices and the calculation of the current, voltage, and cable lengths, the calculation of the cycle time per Profibus line is important for dimensioning a Profibus network. Of course, every user strives at obtaining the shortest possible cycle time. The three main factors influencing the cycle time are the selected Profibus DP transmission rate. The higher the rate, the faster the transmission. But at the same time, the maximum permissible DP copper cable length is decreased. The number of Profibus DP and PA subscribers per line. The fewer devices used, the higher the transmission rate, but by this you need to build more lines and DP master. The number and data width of the selected function blocks per transmitter. The fewer function blocks used, the higher the transmission rate. But at the same time, you cannot take full advantage of the entire range of possibilities offered by advanced smart field devices. There are also other factors which can affect the cycle time. However, they are of minor impact and are not considered for cycle time calculation. Now let's summarize this learning module. So, what have you learned so far? The type of communication on a Profibus line between the masters and to the slaves. The process of field device installation and address setting, offering three different possibilities. The principle of user data communication, where the master polls the slaves one after the other. The structure of the field device diagnosis, which provides useful information from the field devices. The concept of the Profibus profile with its block structure, showing the great opportunities provided by the Profibus Protocol. The structure of the field device status information and the measuring value, which helps to permanently transmit important information from the field device. The main factors influencing the cycle time, which allow for optimum device distribution in the planning phase.